Ladies and gentlemen, hello and welcome back to Dubious Engineering. We've got a special project to show you today. Let's get stuck into it.
I've made myself a little clip. So here they are. Let's clip them together. Bang! Absolutely solid. In there, absolutely solid.
Hello everybody, and welcome back to Dubious Engineering. This is in the style of Big Clive. If I had a slight Scottish accent and I was an electronics wizard, I'm sure you'd really appreciate this. But as it happens, neither of those facts are true. I do, however, or have in this case, created something. I'm going to start with this one. This here is, and you'll hear it click in place. Look at that. This here is a self-releasing sort of rucksack clip. Look at that. Press the two buttons. Bonk. Out she pops. And I designed this just because I wanted to. So actually I started with this design here. And as you can tell, it's it's pretty useless. But what I wanted to do was take you through my many design iterations. And the other thing I should probably do is show you what it looks like when it's in software. So let's go ahead and fire up the software. I use this software here called Shaper 3D. There's many things that I've been designing on it, including, can you guess what that is? That there is a crystal radio set. In fact, I'm going to give you a little preview of it. There is a crystal radio, so there'll be a future episode on that. So what have we got? Well, we've got something that sort of resembles a rucksack clip, in the sense that it's got a squeezy pronged clip that has these two little outliers. So these are flexible. This is all printed in PLA, by the way, which is quite interesting. These are flexible here, so you can squeeze them, and these are flexible here, so you can squeeze them. But getting those tolerances right and making sure that everything worked was quite interesting. And that's the journey that effectively I want to take you through. How I started off with that and how I ended up with this. And it took a little bit of effort and a little bit of thinking. Let's zoom in and get stuck into some of these weird and wonderful designs that I've come up with. And let's have a quick look at the benefits and the failures of each design. This is the original, which literally was made out of clear plastic. As you can see, it's got two little tabs on it that bend, and if you run your finger down the side of it, you might even just about be able to see that there's actually a little tiny tab there, but there's not much of a tab. And then on the inside, you've literally got two little windows on either side, and the rest of it is just sort of like a socket. As you can tell, that doesn't work very well. This was the next iteration. This one worked a little bit better. Now what I did with this still doesn't work that much better, but what I did with this, if you look down in the center of this, I added a little bit of structural support to this guy by including this lump in the middle and cutting out a lump from here. That gives us much more structural support in this receptacle, and then, well, the female section of the clip, and then the male section of the clip. Clearly then I realized I needed to make these little tabs on the side bigger, and as you can see, there's a little bit more engagement, and it actually sort of stays in there a little bit more as well. So that was version 2. So version 3 here, this guy was printed in this orientation. So this was printed flat on the table, and this was printed vertically. And the idea behind that was because when you start getting holes that are that big and you try to print when they're flat on the bed, what happens is that as you're trying to print that molten plastic just hangs. It just can't stretch from that side to that side without sagging, and you know, so hence the reason I decided to start printing this one flat on the deck and this one vertically. So this one's a little bit better. It's a bit bigger, but there's a lot of play in it, as you can see there. So I thought to myself, right, we'll fix that, and then on top of that, as you can see, it wasn't exactly hard to undo it. So I need to make these tabs bigger again, I thought. And as you can see here, we've got two large open holes, but we kept the structural design, that little centerpiece there, in to make sure that we've got a good structural support, so that if this is getting squeezed when it's open, it doesn't break, and also if you're pulling in this direction, it gives it a little bit of extra support. So next one, I thought, well, let's increase the size of these tabs here, and they are quite a lot bigger now, and let's make some kind of mechanism to give it the ability to be able to release itself. And clearly I made a mechanism that unfortunately won't fit like that, but then I thought to myself, well, the likelihood is you're going to have something coming out the back here. This has got supports printed inside of it, you can pop those out, but ultimately I thought to myself, right, okay, if we make it like that, then you can squeeze that and that'll all just hang in there. And this guy, when it's in place, well, now it's got a lot less slack. Remember, this guy had an awful lot of slack in it there. So I've tightened up the tolerances on the position of those tabs. And this just about does the job. So now I had something that was self-releasing, but it was in 3 parts. And I thought to myself, well, it would be nice if this was all in one part. So, shing, here's one I printed that was in one part. And I printed this one vertically. And unfortunately, as you can see here, I've broken these little tabs. And the little tabs were connected on the side of it. And the idea behind those little tabs was clearly as an inbuilt release mechanism, but because I had printed this vertically, when you put pressure on those tabs, because the build layers go up like that, the tab just snapped off immediately. There was no structural integrity to it because it was built with layers that were sandwiched together like that. So back to the drawing board. It does work, it's quite nice, it locks in place quite well, but the quick release didn't work. So with this one, what I decided to do was print this flat on the bed and make these tabs so that they had a bit of structural integrity, so that the layers again were like this, yeah, and the filaments being printed like this in a horizontal format instead of a vertical format, so that when you put pressure on that, you're not trying to shear 2 plates apart from each other. So so the grain, I suppose, the grain of this is much better. Right, so let's try it. There we go, clips in place, good solid clip that now. And this guy, my goodness, yeah, I didn't get my build tolerances right when I made this, so these guys here don't move far enough in, and I put these extra little tabs on the side here, these little overhangs, to stop them, to stop the operator from squeezing it so hard that it broke off. So those are relief tabs, if you like. Yeah, But if you really give it some beans, there we go. Now I gave it to my wife and my wife couldn't operate it. So I said, right, okay, well clearly I need to change the tolerances in the design. Next version. So here's the next version. This version here has better tolerances. And when you squeeze it, oh, look at that, it actually shoots out at you. So I got the tolerances right on the other side, but unfortunately, it does mean that now it doesn't actually stay latched anymore, but you can use it to shoot people for fun. So I tweaked those tolerances again, and I got a bit clever. I thought to myself, you know what? I'm going to put some extra support in here so that when you're printing this, it's less likely to fail, and it'll give me a little bit more structural integrity. I thought, yeah, okay, that'll be brilliant. What's wrong with this picture? This clip clearly won't lock in place. I'm an idiot. I completely ruined that one. That was just a mistake. So back to the drawing board. I've ended up with this. And I am reasonably happy with this clip. It's solid, it doesn't pull apart, and these guys release it without too much pressure, but don't shoot it across the room. It's got a good snap and lock in position. Look at that, bonk, there we go. So this, ladies and gents, is what I've ended up with. I'll put the STL file in the comments section, in the description section. So if you decide you want to print one of these, you're welcome to it. Please don't use it for anything too serious. I haven't tested it, I haven't hung weights on it. Anyway, this really is quite solid. It's very difficult to pull apart. The release buttons are quite easy to operate. It's completely reversible, clearly, you know, that's just basically a mirror from that side to that side, mirror image. But yeah, I'm happy with this. This is now my go-to solution. Well, ladies and gents, thanks ever so much for watching. Can you believe we went from that fail to this in a number of days of lying in bed and designing stuff in Shaper 3D and printing lots and lots and lots of versions of it. I finally got there. I'm happy. Thanks ever so much for watching, peeps. If you haven't subscribed, please do so. Give us a good old thumbs up, and we'll see you in the next one. Stay safe, people. Take care. Have a wonderful weekend. Cheers and beers. Bye for now. Ladies and gents, thanks ever so much for watching. As always, really appreciate a good old thumbs up. If you haven't subscribed, please do so. Go ahead and hit that bell button and all that kind of madness. And we look forward to seeing you on the next one. If you haven't seen some of our other videos, go check them out. They can be quite interesting, mildly educational, and a little bit fun. Take care, people. Stay safe and have a wonderful, wonderful weekend. Cheers and beers. Bye for now.